Advanced Transport Networks. If this is your first time working with transport networks, please watch the linked videos describing the creation of transport networks first. When building transport networks in visTable, focus only on real transport routes, don't recreate material flows. The cleaner your transport network, the better it performs. It is crucial to understand the difference between material flows and the transport network it uses. Here's how it works. We begin the material flows, the connections showing goods moving between processes. We want these flows to operate within transport areas, the physical zones where movement occurs. The network itself consists of transport paths which we layer onto these areas, creating designated routes that guide and contain the material flow. So the procedure to create material flow visualization is always create material flows as direct connections, define transport areas, create transport networks within the defined transport areas. Switch on material flows bound to the path options of the transport network. This principle holds true even for specialized transport areas such as conveyor systems. When you properly define the transport networks, the material flows will make the best use of it. Now that we know the procedure, let's look at how to avoid some common mistakes. Many users add extra branches thinking they'll improve the material flow, but the system automatically finds the shortest path without such branches. Make sure to delete the nodes of the branches and not just the connections to avoid possible errors. Also remove any unnecessary nodes within the transport paths. These standalone mid-path points don't help routing, only keep nodes at crossings or branches. Important exceptions. Transport means like worker, direct, or gantry crane completely ignore transport networks. Trying to force them onto paths will not work. Routing through the network happens in two clear steps. First, the system snaps from the source or the sink to the nearest usable transport network edge. Then it calculates the shortest path throughout the network. In certain cases, adjust connection points of sources and sinks to prevent inefficient routing paths through your network. When you see a pink dashed line, it signals a routing failure, typically caused by one of two issues. Either you have disconnected sections in your transport network, or there are problems with the set transport direction of the net edges. You should avoid separate network sections. Here you can see what happens. A frequent issue arises when universal and transport-specific networks mix. Either use one universal network or only use individual transport-specific networks. To fix this, select the network and open its properties. Since in this example one network is forklift specific, we can change the other network from universal to manual transport. Something that can also cause routing failure are one-way transport paths. To fix these, you can change the direction or make it a two-way path. Another source of errors are dummy connections if network nodes are not connected correctly. To check this, drag a node. If the paths don't follow, you've got a broken link. To fix this, just drag the node onto the network path to connect it. If everything is correct, the paths will now move if you reposition the node.